Welcome to the fourth and final part of the video of making the right rudder plug of the UWS-1 Ultralight Airplane from the Ultralight Airplane Workshop. I'm Leon. This portion of the video, part 4, leaves off where part 3 ended. If you haven't seen part 3 yet, go ahead and click on this link up here in the upper right hand corner and it'll take you to part 3. And if you haven't seen any of the videos yet, go to part 1. Part 1 will give you the plan for making this plug. Part 2 you can skip if you want to. It's where I kind of went down a dead end on how to manufacture the plug. In part 3 I started over again, and in part 4 we're finishing up this plug. Since it's been a few weeks since part 3 came out, let me remind you that we're making a plug for making composite carbon fiber parts for an ultralight airplane. A plug is basically the same shape of the part that we want to make, but it doesn't have the internal detail. It's just the outside shape. What we do with the plug then is we make a mold, and a mold then will be the negative of our shape. Once we have the mold, then we can make our carbon fiber composite parts using vacuum resin infusion. Now the processes you're going to see in this video aren't necessarily a recommendation for how to finish a plug. It's just something that I'm trying to see if it'll work. It's kind of an experiment. A lot of what I'm going to be doing in this video is something that I've done briefly in the past, but I really don't have a lot of experience with it, so I'm going to be learning a lot in this video. Now this video is pretty long because there are a lot of steps to what I'm going to do to finish this plug. Well, I'm anxious to finish this plug, so let's get started. What you're looking at here is the sanded rudder plug for the UWS-1 Ultralight Airplane. And I've used some drywall mud to fill in cracks and crevices and dents. I found out the hard way that this foam dents way too easy. I mean, just barely touching it. In fact, just rubbing your fingernail across it will put a dent in it. So I've ended up putting quite a few dents in it. Now some of the cracks and crevices I knew about, and it was pretty much intentional. But there were accidental ones, numerous accidental ones, that I ended up having to fill. Now the reason I'm filling this first and not just covering the whole thing to start with is this drywall mud will shrink. And so any deep spots I actually filled now. Thinner ones I waited till later. But what I'm doing right now is filling the deeper ones. So for example, the slot that I made for the spar caps, that's still pretty deep in there. The spar caps didn't come all the way up to the surface. So I wanted to fill that in first. Let the drywall mud shrink, because sometimes if it shrinks a lot, it can crack. So I wanted to make sure that wasn't going to happen. So I filled those first. In between the blocks of foam and adjacent half airfoil templates, there's also sometimes a crack up to a millimeter and a half. So I wanted to fill those too. Probably didn't need to, but I wanted to. And the trailing edge. The foam wasn't glued all the way to the trailing edge in a few places. So where I noticed it wasn't, I removed it. The reason I did that is because when I'm sanding, if it isn't glued down, it kind of pops up, and so it moves down and pops up, moves down. I just wanted to remove that problem, so I'd cut those areas out. Of course, that left an area that I needed to fill. I'm not really great at applying the drywall mud yet, so once the drywall mud dries, there are usually little spikes of it that are kind of sticking up. One of the problems with those is that they're pretty hard. So if they get on the table and I set down the foam on them and move the foam around, they'll leave some nasty gouges and tracks in the foam. So I like to run my hand along that dried mud and knock those spikes off there, and then brush off the table. I've been setting my foam plug on a piece of foam on the table, just in case something hard does get in between my surface and the plug. So if I do get something between the plug and what it's resting on, at least it's going to produce a shallower gouge or less gouge. And something could get embedded in the foam that I'm setting my plug on. So I run my hand across it to try and knock anything off that might be embedded in it. Once the mud that I used to fill in the deep grooves and gouges has dried, I just quickly knock off the high spots on it before I apply the next round of mud. It sands really easy and quick, so I'm just using some 220 grit sandpaper on a small sanding block to knock down the high spots on the dried mud. I noticed when I was first starting to apply this drywall mud to the foam, if I was trying to put on a thick coat where thick is a millimeter or so, it did not want to stick to the foam. But if I put a thin coat on and really pushed down, it did stick to the foam. What I think is happening is when I'm trying to put on a thick coat, you don't really put a lot of pressure on your spatula. You're trying to kind of skim and float that spatula across there to put on a thin coat. I think what that does then is it fails to push the drywall mud down into the pores of the styrofoam. And so it just doesn't stick. It's kind of sitting on top of the foam, doesn't do anything. But when you put a lot of pressure on and put a thin coat on, it's forcing that drywall mud down into the pores of the foam. And then you can come back and put a thicker coat on because the mud sticks to the mud fairly well. So what I generally end up doing when I'm doing a fairly wide coverage of this mud on the foam plug is I'll first do a thin high pressure coat over a large area. Then I will come back and do a thick coat being like a millimeter and a half, which is something like a 32nd of an inch up to about a 16th of an inch. And that seems to work out fairly well. Now I said a 32nd up to about a 16th of an inch, but I think I really ended up with a 16th of an inch and up just a little bit. In some places almost 2 millimeters. So almost, 80 thousandths, something like that. And that's because I really don't trust the job that I did sanding the foam, getting it nice and faired in between my half airfoil templates. Now running my hand over it, I could tell, especially on the leading edge, it didn't quite feel right. Overall, it felt pretty good, but I really didn't trust myself. So I decided, you know what, I'm just going to put her on thick and sand it down. I know it's going to take more time, but I feel confident that I could probably get a much more fair finish and feel pretty good about it if I start thick and then sand it down. Of course, in the future, if I decide I did a fairly good job of doing the sanding of the foam down to the templates, then I'll probably put on thinner coats. Because even though this drywall mud sands pretty easy, it still does take some time and effort to sand it down. And we don't want to forget the ends. Now, although the big end was pretty flat, I did a fairly good job of getting the planform end and half airfoil templates lined up pretty good. Covering those weren't too bad, but the small end, I had a little bit trouble with one of the airfoil halves. So I actually had to do a fairly good job of fairing on that end to make it flat. Now that 60 to 80 thousandth drywall mud has dried, time to take it back off. Now since I did not do a really smooth job of putting it on, there are lots of high spots. So I start out by very gently going through with this 80 grit, fairly stiff sanding block and removing the high spots first. Now by doing this, once I start doing my regular sanding, I hope that I can reach the foam surface at roughly the same time over a broader area. If I leave these high spots in, it's possible that a high spot will take much longer to get down to the surface than a low spot would, which might be getting sanded at the same time. So getting rid of those high spots should help. Now, like I said, this is a fairly stiff sanding block, and it's 80 grit sanding paper. I'm using this really coarse grit to remove a lot of drywall mud quick. And I try to not stay in one spot and sand. I'm slowly moving from like the nose to the trailing edge, from the trailing edge back to the nose. I'm trying to keep from concentrating on any one area. And again, I try to get down that foam surface at about the same time everywhere. Once I start to see a little hint of pink, in other words the foam, or I get a little dark area, which I think is a template, then I know I'm getting close. Then I switch over to my 200 grit sanding block. And this just happens to be one that I made myself out of some 1/8 inch hardboard, and I glued a few little handles to it. This is much more flexible than that rigid sanding block was. Since I'm not going to get down to where I want to be at the pink foam or the templates at the same time over the entire surface, I'm using a slightly more flexible sanding block to remove the slightly thicker places and reach that foam at about the same time. But again, I try not to concentrate on any one spot. Now things are a little bit different here. I don't just keep going over the whole thing. Once I see some pink, I avoid that area from now on. I only concentrate on the areas that still look like it has thick drywall mud. And when I see some pink somewhere, I try to avoid that area. And that's a little easier to do with the slightly more flexible sanding block. It would be a little more difficult to do with the stiff one. Now, doing this sanding, especially since this drywall mud is so thick, produces a massive amount of fairly heavy dust. It doesn't just fly away. A lot of it just stays right here on the part. And so occasionally you either have to brush it off, or in this case I went and got my vacuum cleaner and cleaned up a whole bunch of it, because occasionally it gets hard to see what you're sanding. You may have already reached the pink, but you've got so much dust on there you can't see it. The dust just gets moving around, so you have to clean it off every once in a while. And here you can see, after quite a few minutes of sanding, I'm getting pretty close to being done on this side. You can see pink of the foam, you can see the dark lines of the airfoil templates, and I'm just about there. There's just a little bit more on the narrow tip to do, and a little bit more on the trailing edge. Not much, but just a little bit. So at this point, I'm almost done sanding. Once the other side is done sanding, it'll be time to start thinking about fiberglassing. Since I'm fairly happy with the surface finish of the drywall mud on the foam, it's time to go ahead and think about putting fiberglass on. I want to put fiberglass on this plug to make it tough, and fiberglass is fairly cheap. The reason I want to make it tough is, particularly with the experience I've had with just the bare foam, it is easy to nick and dent that bare foam. I think with 2 layers of fiberglass, in this case 200 gram per square meter fiberglass, plain weave, e-glass, will make it tough enough. And by having 2 layers, I can sand into that top layer a little bit without having to worry about damaging the integrity of the bottom layer. For the fiberglass that's going to go at the top and bottom of the rudder plug, I made a couple of paper templates, one for the top and one for the bottom, and I cut about a 1/4 inch out from the airfoil shape so that the fiberglass will be just a little bit bigger than the surface area I'm going to put it on. I don't want it to be much bigger though. You may already know that if you have a whole bunch of fiberglass overhang at an edge, particularly if you get wetted down with epoxy, that is a whole lot of weight hanging out over that edge and hanging down. What can happen is that inboard of that edge, since you've got so much weight hanging down, and the fiberglass does have some stiffness to it, you're going to have the fiberglass inboard of that edge popping up, and you'll essentially have a great big old air bubble running all along that edge. So the less fiberglass you have hanging out past the edge, the better off you are. The fiberglass on the rudder plug is all simple wet layup. The epoxy that I'm using doesn't seem to have an amine blush problem, so I'm going to leave off peel ply on this, so it's a simple wet layup. As with most of the wet layups I do, I like to put down a layer of epoxy on the plane surface first. And it's a really good thing I did, because the drywall mud here on the end of the rudder really soaked up a lot of epoxy. But I'm actually happy that it did that, because I was a little bit concerned about how well that drywall mud would adhere, in this case to the templates, but also to the mud. And the fact that it soaked up so much epoxy is good, because that means that epoxy should soak through that drywall mud and to the wood and really help to adhere the drywall mud to the wood. So I'm really happy about that. I then go ahead and just put down the first layer, and in this case I'm using a foam brush, disposable foam brush, to apply the epoxy, and I think it's fine for this particular application. All you really need to do is get the epoxy to soak into the fiberglass. I'm not really looking for lots of compaction or to get rid of every last little air bubble. Don't really need to do that for this particular application. And then I put on my second layer, make sure it's soaked down, and then I do squeegee any real excess off. I don't want like big puddles of epoxy on top. So I'll remove some, but I don't try to remove all the epoxy that I can. There's no need for that. In fact, if I do that, that just means I need to do more filling with drywall later to fill in the texture of the fiberglass. So I just remove any puddles or drips or anything like that. I forgot to mention that before I started putting down the epoxy, I wrapped the airfoil in paper to catch any drips that I might make. Another thing that I did is I masked off the very top of the airfoil right up against where the fiberglass is going to be with easy to peel off masking tape. The reason I did this is after about an hour and a half after I put down the epoxy, I can go back and remove that masking tape, and that will remove any epoxy that got down onto that masking tape, and it won't glue the masking tape down. After about an hour and a half, the epoxy is tacky, and since the tape is easy to remove, I don't disturb my fiberglass at all. Here's the other end of the rudder. Unfortunately, I let this end cure far too long to be able to remove that masking tape from around right underneath that fiberglass. And I also let it cure too long to do the next thing I want to show you. I end up letting this cure about 10 to 12 hours, somewhere in that range. So it's really too far long cure to do what I want to do, but I decided to go ahead and do it because I forgot to record it the first time when I did it right. But if you let it cure the right amount of time, in this case the epoxy would be about 6 hours, 5 hours, 6 hours. The epoxy will no longer be tacky, or maybe just tiny little bit tacky, but more importantly, it will have firmed up quite a bit. It won't be stiff yet, it won't be fully cured. It's kind of in between. It's slightly pliable. What you can do is take advantage of this. You can use a razor knife to cut off the excess fiberglass. And that's fantastic because then you don't have to use a really rigorous method to try to cut it off, and you don't have to sand it. Not nearly as much. When I cut it down to within about a 32nd of where I want it to finally be. I don't want to accidentally cut into the foam because right now there's no fiberglass on the other surface. So I cut down to within about a 32nd. Then I go ahead and let it finally cure. And that takes about 20 hours with this epoxy. Then I come back with the sanding block and sand it right down to where I want it to be. And this saves a lot of time and effort by cutting off the excess fiberglass when it's semi-cured. But like I said, the 10 to 12 hours that I waited on this one is far too long. I'm having to use a lot more effort than if I had only waited the 5 or 6 hours. The way that I had taped off the airfoil shape when I was getting ready to fiberglass the ends, now I'm going to do it the other way around. I'm going to tape off the ends so I can fiberglass the faces of the airfoil shape. And again, the reason I want to tape off the ends is that I don't have to do epoxy cleanup on the ends. In other words, I don't have to sand off drips and such. As long as I remove that tape about an hour and a half or so after I fiberglass those faces. Once I put the tape down, I come back with a sharp knife and I cut right down to the edge. I don't want that tape sticking up where I'm going to have fiberglass coming out over that edge. I needed to cut out 2 pieces of fiberglass for the face of the rudder. I decided to use a template to do that. And I just happened to have some of this craft paper that was used as some packing material on something I had ordered, and I'd kept it around. And I decided it would make a pretty good template. It doesn't need to be terribly accurate. In fact, I'm going to draw a mark on it where it's about 3/4 to 1/2 inch larger than the airfoil. And all I have to do is just kind of roll the airfoil over and mark the rest of it. And it turned out that this worked pretty good. I'm going to cut 2 pieces of fiberglass. And this fiberglass, like I said before, is 200 grams per square meter, plain weave E-glass. Each of my 2 pieces is going to be able to completely cover the face of the rudder plug. So I won't have any overlaps, I won't have any seams. It makes it way easier to sand it down. I've already used the template to mark out where I'm going to cut the fiberglass. All that's left to do here is cut it out. One thing I didn't do here that I probably should have is mark a center line for the leading edge. That would have helped me line it up on the rudder much easier than it turned out to be. And I want to roll up the fiberglass to make it a little easier to handle. I want to try to keep it with the same shape as I have here on the table. If you're not careful with this plain weave and lots of other weaves, you can lose the shape. You can get it all cattywampus. And I want to try to keep the shape. So I try to carefully roll it up. In order to cover the whole face of the plug in one go, I needed some way to hold the rudder up in the air so none of the faces were touching a table. So I made this little rig to do it. There are screws that are kind of pressed into each end, kind of suspending it up in the air, and it rotates freely on those screw ends. And they're not screwed in, they're just pressed in. And that turned out to work pretty good. I mixed up quite a bit of epoxy here to do these 2 layers of fiberglass. And since it was such a large amount of epoxy for that little cup, I decided to put it in a bucket of water to try to keep the temperature down so I'd have extended pot life. But I ended up putting the epoxy on so fast that it ended up floating in that bucket pretty quickly. So I really don't think I gained anything by putting it in the bucket. And in fact, I had to mix another cup a little bit later on, so I didn't even bother with the bucket. As I do with pretty much all my wet layups, I wet the surface first. I think I mentioned before, this drywall mud really soaks up the epoxy. So my wet surface isn't quite as wet as it normally is. But the reason I want to wet out this surface is when I put my first layer of fiberglass down, it gets wetted from both underneath it and from over the top when I add more epoxy over the top. So it helps reduce the possibility of air bubbles and not getting good adhesion between the fiberglass layer and whatever's underneath it. This hinge mechanism that I'm using to hold up the plug worked out really well. When I'm on one side of the plug, I can tilt it up to make it a little bit easier to apply the epoxy. And then when I go to the other side, I can tilt it that way, and it'll make it a little easier to apply the epoxy. So far, I'm really liking this way of holding up this plug as I'm working on it, putting on the fiberglass. After I had the surface all wetted out, it's then time to put on the fiberglass. Now, I had a little trouble with it. I probably should have rolled up the fiberglass 90 degrees to the direction I actually rolled it. I had an idea of how it would work out, and it didn't quite. This is also where, if I had marked that leading edge on the fiberglass, it would have made it much easier to line it up on the plug as I was rolling it out and adjusting it. I could adjust that line right on top of the leading edge, and I wouldn't have had to mess with it nearly as much as I did. So if I go to work on another airfoil shape, I'll have a little better idea what I should do there. And then after I get the fiberglass placed pretty much the way I want, then of course it's time to put on another coat of epoxy and wet out that fiberglass. Try to get rid of all the air bubbles, try to move it around as needed. And one of the things I did here that was a little unusual for me is, as I was trying to get the air bubbles out, I decided to just do it by hand. Use my gloved hand to run those air bubbles out. Normally, if this was horizontal, or if it was fixed and not moving around, I probably would have done what I normally do, which is to use a squeegee to remove all the air bubbles. This time, for whatever reason, it just felt right to use my fingers instead, so that's what I did this time. You gotta be a little careful doing that. You want to make sure your glove doesn't bust while you're doing it and end up exposing you to the epoxy. But it turned out fairly well. Unfortunately, my memory card ran out of memory, so we don't get to see the second layer, but it doesn't really matter. It's just basically doing the same thing that I did on the first layer. This time I waited the appropriate 2 hours after I applied the epoxy to come back and remove that masking tape that I had put on the two ends of the plug. I sanded a little 1/4 inch by 1/4 inch stick with a little sharp end on it so I could reach in there and peel the ends of the tape up so I could then grab it with my fingers and pull it off. So I was able to peel off all that masking tape, and it didn't get cured on there and have to be sanded off. I also waited the appropriate amount of time this time, which is about 5 hours, to trim off the excess fiberglass. The fiberglass is not fully cured. It's still fairly flexible, so it's very easy to cut through it with the razor knife. Somehow an air bubble got past me. I didn't see it when I was laying down the fiberglass. So I got this little 1 inch by 3/4 inch air bubble that's on the first layer, and of course it's showing up on the second layer. So what I ended up doing is sanding on it a little bit and then cutting out with a razor knife. Then I cut out a little patch about 1 inch by 1 inch, laid it down, wetted it out, and then put some peel ply on it and let that cure. Since I didn't use peel ply on the fiberglass when I laid it down, the fiberglass has a lot of texture to it, and I need to fill in that texture before I start putting on my primer layer. I decided to go ahead and use this drywall mud for filling in the texture also. So basically I need to just cover the whole thing again with this drywall mud and then sand it down. Very similar to the way I filled all the pores of the foam and then sanded it down. Pretty much the same thing. The amount of time I spent trying to fill this texture makes me think that next time I'm going to go ahead and do the peel ply. I think it's worth the expense of the peel ply to reduce the amount of extra drywall application and sanding that I've had to deal with. Then after this drywall mud dries, just sand it down to the fiberglass using a 220 grit sandpaper. Well, my plug should be awfully close to fair, so it's finally time to start putting on some primer. Now I'll use the primer to do the last little bit of filling in texture and pinholes. At least that's the plan. You'll find out here in a few minutes that I actually had to go back and do some more drywall mud. Now my intention here on this very first coat of primer is to just mist it on, just a very, very light, thin misting. Now my first spray across the bottom failed. I put it on way too thick. But the idea is you put on this very thin mist coat, let it dry for 2 minutes or so, and then come back and put on the wet layer. And it should help the wet layer adhere much better. And once again, I am really happy with this jig that I set up to hold the plug so it'll rotate around so I can paint the whole thing in one go. I don't have to use multiple spray and dry steps in order to get one layer on the whole part. The primer I decided to use, at least initially, to try to test out is Stewart Systems Eco Prime. And this happens to be charcoal gray. The model is the E7525. And it's a quart can. One of the reasons I decided to use this is it's water soluble and water cleanup. And I thought that's probably a pretty good idea to use on this styrofoam filled plug. Something that might have one of those ketones in it or some other kind of solvent that can eat polystyrene probably isn't a good choice, at least for the very first coat. And I thought this water-based primer might be a really good choice. So that's what I'm using initially, and I'm actually using it for the next few layers also. I'll use something different for the very final layer. After I finish putting on the wet coat, I let this dry for about 2 hours. I think it was 2.5 hours at about 75 degrees. And it got pretty dry. I was very happy with it. This is a fairly fast drying primer. And then after it finished drying, it was time to start sanding. Now initially I started using a 320 grit sandpaper on a small sanding block. And so I used this sanding block and sandpaper to sand this first primer layer for the whole part. It worked reasonably well. The 320 grit did gum up just a little bit, not much. Occasionally I'd have to turn over the block and flick off a little piece of gum. For the most part, it worked pretty well. On later layers, I did finally switch over to using a much larger sanding block with 220 grit initially, and then come back down to 320 a little bit later. I ended up doing a tremendous amount of sanding on this particular layer. I found that this first layer of primer soaked into the drywall mud that was down in the crimps of the fiberglass. Those crimps creating the texture on the fiberglass. So since that primer soaked down into that drywall mud, that texture still came through this primer layer, unfortunately. So I ended up sanding a lot of it down. And one thing that really came through was where I had put that patch that I mentioned earlier, where there was an air bubble underneath the fiberglass and I had cut it out and replaced it. That stuck up quite a bit, and so I sanded on that a lot. And in fact, on the second layer, I ended up sanding on it a lot more, and finally got it down flush with the rest of the surface. So this first primer layer was not a bust, but I was a little disappointed in how well it worked out. But I learned a lot, and the next time I'll do a better job. The second primer layer worked pretty well. There was just a tiny hint of the texture still coming through, so once I sanded through that, the third layer then looked really good. When I was sanding the leading edge and the nose area on this second layer, I was noticing when the light was on it a certain way that there were some flat spots on it. Somehow I had done a little excessive sanding in little spots along that nose area, and there were, instead of being nice and curved, there were some little flat spots on there, and that just bugged the heck out of me. It's possible that it would never have been noticeable up on the airplane, and it would probably have not affected the aerodynamics, except when the rudder was significantly deflected, and then it probably wouldn't matter anyway. But it just bugged the heck out of me, so I decided to try to fix it. To fix this flat spot issue, I decided to add some more drywall mud. I wanted to somehow put a faired shape on this leading edge, on the nose, and drag it along there to try to drag some drywall mud along into the shape I wanted. And I did a little searching, and I finally found something that worked pretty well, and it's one of my early carbon fiber test samples. It was a fairly thin one, so it was stiff enough to kind of give the faired shape that I wanted, but still flexible enough that it would bend around that curve. And so what I ended up doing is just dragging it along that drywall mud on that leading edge, and it worked really well. Now right now it looks like there's a whole lot on there, and there is a little bit extra on there, but after I sanded it down, it looked way, way better than it had been. Now again, I had an issue of when I put the next layer of primer on there, it soaked into that drywall a whole lot. So I sanded it down again, and that was the third layer, and when I put the fourth layer on, it looked fantastic. When the fourth coat of primer dried, I thought it looked pretty good. I hadn't sanded it yet, but I thought it looked pretty good. So this time I decided I was going to put a guide coat on it. And that guide coat, when I go to do sanding, will help me see spots that I have not sanded. And I'll just have to keep sanding until all those dark spots are gone. And if it all works out like I hope it will, that means I should have a very flat, fair, and smooth finish. Now if I see dark spots that I just can't get to, like pinholes or some of the texture that's still shining through, I'm going to have to fill those holes and do another coat of primer. For my guide coat, instead of buying something that's specifically for guide coat, I thought I'd do a little experiment, and I happen to have a can of flat black enamel spray paint in a rattle can. So I thought, you know what, I'll just try that. I need to get rid of it anyway, so we'll try that and see if it works as a guide coat. Now we get to find out what that guide coat will do. I'm using this mostly flexible sander that I made first. And even with just a few strokes across here, we can already see that there are some high spots and some low spots. And this particular sanding block that I'm using, it has 220 grit on it. And the amount of flexibility it has will show up ridges that are maybe up to 3 inches, 4 inches apart, maybe even 5 inches. Anything beyond that's less likely to show ridges. It's liable to go ahead and bend down and sand into the valley. But at least the close together ridges, it shows up pretty well. And we can already see that there are certainly some high spots and low spots on this rudder plug. What I need to do is keep sanding and keep sanding until I can no longer see the dark spots. That will sand down the ridges down to where the valleys are. And by the way, I probably didn't let this primer dry enough. Probably need to dry about another 2 hours because it still did kind of gum up the 220 grit sandpaper on the bottom of this block. But it still did a pretty good job. It only just did a little bit of gumming. Well, now let's find out what happens when we sanded down all the high spots down to the low spots. As you can see, there were some really high spots that got sanded all the way through the primer. And this was the fourth layer primer. So I really should have started using guide coat on some of the earlier layers of primer. But on this layer, I got sanded all the way through all of the guide coat, so the high spots should be pretty much gone. And here's a really quick view just to kind of help show you the difference between a side that has had all the guide coat completely sanded off and a side that still has the guide coat untouched, hasn't been sanded yet. So you can see there's quite a bit of difference. It's fairly easy to see the dark spots as you're sanding it down. So I'm really hooked on this guide coat and I'll be using it from now on. The primer I've been using up to this point is a water-based primer, and it's been working pretty good. I've been fairly happy with it, but it is water-based, and even on the instructions it says that if you happen to get it damp and you rub on it, it can rub off. So I didn't think it was really an appropriate primer to try to get a nice glaze, smooth finish on it that I could use to make a mold. So I'm going to have to cover it with something. So I decided to put on a sandable polyester primer. I decided to try Duratec Gray Surface Primer. The model number on that is 707-002. As I mentioned in a recent composite tips video, I made a mixer to mix up this polyester primer because the solids in it had all settled out and I could not get it to mix with a stick. So I made my own little mixer and mixed it up. And instead of buying one of those little measuring cups to try to measure out how much catalyst to use, I decided to use a scale and I just weighed it out. And I was happy with that result. What I was not happy with was the spray result. This primer was much thicker than my previous primer. I had put a bigger tip on it. I had been using a 1.8 millimeter. I moved up to a 2.2 millimeter, but I did not have this spray gun set right. I thought I had it set right. I did a few little test sprays over on the side, but I knew I only had about 12 minutes to get this coat on and then start cleaning out the gun. Otherwise, that polyester primer would start setting up the gun and it'd be pretty much impossible to get it cleaned up. So as soon as I started getting some polyester coming out on spray, and it looked like it might be okay, I just started spraying it on. But after that darn polyester had cured and I took a look at it, it was coarse. I was getting large spots coming out. Now, when I say large, it's probably something like, half a millimeter by 1.5 millimeters in size. But that's a pretty darn coarse surface. And it's porous also. I would have to come back and put another layer on to make sure I had enough that was fully covered. So I ended up sanding off this first layer completely. So I did a second layer. That time I thinned polyester with 5% MEK. Well, I had almost exactly the same result. So I ended up letting that cure, sanding it off again. Now by this time I'm starting to get a little bit of a buildup of my polyester primer. Not much, but almost all of it's been sanded off. So I went for a third time. This time I thinned it with 10% MEK. And I spent more time, about another minute, 2 minutes, test spraying. And I ended up having to cut down the flow rate a whole lot to get it to come out as a fairly fine spray. And this time I got a great finish. I think the MEK also helped prolong the pot life. It took much longer for it to start set up, and it was much easier to clean the gun too. By the way, that first time it had started setting up before I got finished, and I was afraid I was not going to get my gun cleaned out. I finally got it pretty cleaned out. I was able to keep using it. But that first setup, I guess I just went too long, or I put too much catalyst in and had a problem. But this third time, finally, third time's the charm, and I got an excellent, nice, thick, fairly uniform coat. So I let that cure, and then I went to sanding. Although I'm showing wet sanding here, let me talk a little bit more about what led up to this point. I let that third polyester coat cure and took a look at it, and I was pretty happy with the surface finish. So I decided to go ahead and try to finish off this plug with this sanding layer. I started out with 320 grit, and it turns out that 320 grit is pretty coarse. Up until this point, I never really thought 320 grit was coarse, but by golly, it removed that very top skim layer of polyester fast. But it also showed me that I did a good job on the previous primer coats, where I used the guide coat and sanded it down as flat as I could. Because on this coat, which I also used the guide coat on, the guide coat indicated that I did not have high spots. It was almost all perfectly nice and smooth. And then I immediately went to 400 grit, and I did that wet. 320 was dry, the 400 was wet. What I want to do with that 400 is try to remove all the scratches I could see that were put in when I sanded with the 320. Once I thought all the scratches for the 320 were removed, I then moved on to 800 grit. And I used the 800 grit to remove the scratches from the 400 grit. Once I got rid of all the scratches for the 400 grit, I then went to the 1500 grit. Now here it wasn't so much trying to get rid of 800 grit scratches. You could kind of see them if you looked really, really close. You had something that looked more like smudges from where you had rubbed the 800 grit across the surface. So what I'm trying to do there is get rid of those smudges. And what was really fun and great is after I got done cleaning up from the 1500 grit, I could start to see a little bit of shininess, a little bit of reflection. So that was really encouraging. Then after the 1500 grit, I went to the 3000 grit. And there, all I really was trying to do is just try to make sure I got all the surface rubbed down. Try to rub the surface down about the same amount evenly. It was really difficult to see if there were any effects from the 1500 grit to try to remove it with the 3000. So I was just basically rubbing it down, hoping that I was getting rid of the 1500 grit marks if there were any. And then after I cleaned up after the 3000 grit, it was almost shiny. It was very exciting. So I decided 3000 grits is just about all I can do. Really, the next thing to do is to try to polish it. But before we do that, let's take a look at what that 3000 grit finish looks like. As you can see, with this 3000 grit wet sanding, we got a little bit of shininess. You can see the shop lights reflected in the surface. But as we get up here on top, you can also see we have smudges. Smudges from when we were moving our sanding block around. And those are really just very, very tiny scratches all bunched together. Well, let's work at getting rid of those. By the time I got done wet sanding this plug several times by hand with that block, I was tired of working by hand. So I went to Home Depot and I got this little orbital buffing tool. And I bought a polishing compound from Composite and Visions I wanted to try out. This is actually the second side. I've already done the other side, and I learned a little something. I was going too slow on that first side. The problem with going too slow is it's heating up the surface. And that could be one of the problems I had print through that I'm going to talk about a little bit later. When it's heating up, I'm expanding the surface finish, the polyester primer. I'm also expanding the epoxy and the fiberglass. It's not all expanding at the same rate though. It's only heating up right where I'm doing the polishing and right where I've just been, and it's cooling down a little bit. And this can cause distortions in the surface. That could be where I got some of that print through. Now on this side, I had figured that out, and I'm actually running it a little bit faster. When it was getting hotter than I was comfortable with, I was running about an inch every 5 seconds. I sped it up to an inch every 2.5 seconds, and that was better. It didn't get nearly as warm. It turned out though that I was a little bit disappointed in how fast this was working. I gave it the benefit of the doubt and I went ahead and finished out this side, but after I cleaned it off, I was a little bit disappointed, as well as I'd hoped for. But I was still concerned that if I used this on the leading edge, that it might cut faster than I'd like. Sanding blocks certainly cut faster on this leading edge, and I had to be careful when I was sanding the leading edge. So I decided to do the leading edge by hand. But before we get to that though, I just wanted to show you what it looked like after the cleanup. It looks pretty darn shiny after cleaning off the excess polishing compound. But it's a little bit deceiving. This polishing compound has some petroleum distillates in it, and there's still a little bit of that on the surface even though I wiped it off with a dry cloth. So it's a little bit shinier than it really is. If you go ahead and clean it off like with some denatured alcohol, it actually dulls down after removing those petroleum distillates. So this fooled me for a little bit until I thought about it. But now on to the leading edge. I was really surprised that polishing by hand on this leading edge really worked well. I was really happy with the way it turned out, and I'm pretty happy that I didn't use the orbital polisher to do this. I think what happened is that when doing it by hand, you end up putting a little more pressure per square inch than when you're using the orbital polisher. Now there's the drawback that by doing it by hand, you're probably not evenly polishing. There's probably some areas that get just a little more polished than others. But I think after going over it 2 times, maybe 3 times, you get a pretty even polish. And after doing it by hand and looking at it, I thought it turned out fairly well. And in fact, removing scratches by hand is way faster than using the orbital polisher. And again, I think it's just because of the pressure per square inch. And I had 3 scratches that somehow either got added or somehow made it past all my sanding. That's one thing you have to be very, very careful with. You can see this polisher is actually setting upside down. I don't want to set that pad down on anything. If there's a little bit of grit on what I set it down on, then I could actually end up adding scratches to my surface instead of removing them. And you can't see it here, but I also have my plug sitting on a couple pieces of foam that I clean off regularly so no grit gets between my foam and the plug and would end up adding scratches. And although I didn't mention it, I did the same thing when I was doing the wet sanding. Anytime I was ready to change grit sizes to go to the next smaller size, I very carefully cleaned off my sanding block, my table, the foam blocks I had the plug setting on, and I cleaned off the plug to make sure that bigger grit was gone before I moved to the smaller grit. Otherwise, I could get grit underneath that sanding block and I'm just adding scratches instead of removing them. Well, now we're getting down toward the end. It's time to remove some of that leftover petroleum distillates from the polish. And I'm going to use some denatured alcohol to do that. I learned something recently that I didn't know. In some other countries, denatured alcohol is called methylated spirits. And it took me a little while to figure out what that was. But you'll notice that the alcohol, as it's removing some of that petroleum product that's on there, it gets a little bit less shiny. Now, I probably could have done more polishing on this to try to get it down to a super shiny finish, but I don't think that's really necessary. I got a few more steps to do, and that will actually help add a little bit of more shininess. If there's any just slightly rough, not quite completely polished areas, the next couple steps will help to alleviate that issue. The next thing to do is to seal the surface of the plug. Now, the primary purpose for sealing the surface is that it helps to fill in little porous surface features. Now, of course, it can't fill in large ones, but little micro pores, where if you didn't have it, putting resin on top of this, even though you put on a release agent, that resin can dip down into those little pores and make it difficult to remove a part. In this case, it would be the mold we would be making. So the surface sealer goes and tries to fill in those little micro pits to make it easier to remove the mold once we make the mold. Now I put on 2 layers here. That's what they recommend on the instructions. I almost put on 3 layers, but I decided to go ahead and follow the instructions this time. When I put on the second layer, I did it 90 degrees to the way I did the first layer. And that's to try to ensure that I got good coverage on the surface. And anytime you're trying to add multiple layers of something, doing at least 2 of the layers 90 degrees to each other is a good idea. Well, here's the result. It's not perfect. I didn't expect it to be perfect. This is the first plug I've ever tried to make. And it does have some issues. The worst issue is some print through on the airfoil templates. Now you probably won't be able to see them, but I can see on this side where the templates are. Where they are, there's a very, very slight dip. But what's interesting is on this other side, I did not get that print through at all. Now I can only guess at why that is, but I believe when I was wet sanding this side, I did it when sun was shining on it, direct sun, and it did get hot. Now I was spraying it down, trying to keep it cooled down, but it's very possible that when it got hot, the ribs may have expanded a little bit, or the skin may have expanded a little bit and caused the ribs to push up a bit. So when I was sanding, those rib areas got sanded a little bit extra. But now in here, when it's all cooled down, it has sunk back down just a very little bit. Instead of trying to fix it, I'm just going to go with it. Now what I may be able to do is when I make the mold, there will be just a slight bump up where these ribs are in the mold. And I might be able to sand that little bump out. We'll see. The only thing left to do to this plug is to put a mold release on it. I've got this really old free coat 700 NC permanent mold release, and it's, a year past its shelf life. So I put a little bit of that 700 NC just on the top, and I'm going to do a wet layup on it and let it cure and see if it peels off like it should. Should come off very easily if the mold release is still good. If it does not want to come off, it's no big loss, because I don't think I'm going to need this top face or the bottom face for the molds. I'll be using a different method to make the ribs that go on the ends. So for my first attempt at making a nice smooth primer and getting a nice gloss finish on it, I think it turned out okay. I do have ideas on what to do on the next one to make it better. It shouldn't take nearly as many of the coats next time, because I know a little bit better on using the guide coat. And I know a little bit more about using that polyester primer. And I might switch over to an epoxy primer. It's an idea that I'm playing with. I'm probably going to hold off on making the mold from this plug until I have a better idea on the aerodynamic loads. That'll drive how I want to make the parts, and then how I want to make the parts will drive how I want to make the mold. So one of my very near future projects is to be making a test jig so I can do shear tests on some of the samples I've made. And then once I have my shear test results, I can finish my structural design and then make the mold. Well, that's it for this video. Until next time.